Yes, good morning to everyone. Okay, so far in module 2, what are the things we have discussed? On seeing this slide, you can tell. Another topic is module 2 la mudichirukkom nama. Yes, kindly respond. Yes, 8255 mudichachu. Very good, Logus Nega. Okay, then. So 8255 we have completed. Okay, then. Last class and the topic complete panna. Yes, 8253. Okay, 8255 is programmable peripheral interface PPI. Okay, that part we have covered. Then 8253 we have covered. Okay, then memory mapping scheme we have covered. So 3 topics we have covered in the module 2. Okay, so today we are going to learn about the IC 8259. Okay, so it is a programmable interrupt controller. Okay, so can you people guess what this IC is going to do? In total, 8085 microprocessor la ethana interrupt irukku? Hardware interrupt. How many hardware interrupts we are having in 8085 microprocessor? Yes. Yes, 5 interrupts we are having. Yes. What are the 5 interrupts? Trap, RST 7.5, RST 6.5, RST 5.5. Okay. Then, what about the other thing? What about the other thing? INTR, very good. Okay. Out of this 5 interrupt, how INTR differs from other interrupt? Any guess? How INTR differs from other interrupts? Any guess? Yes. INTR have acknowledgement. Okay. Yes, very good, Karthikeyan. That point only I am expecting. It's a non-vectored interrupt. Okay. Why we are having such provision means using 8259 you can expand the number of interrupts handled by 85 microprocessor. Okay, so 8085 can handle up to 5 interrupts. Okay, by default. Okay, if you interface this 8259 with 8085 microprocessor, it can handle many interrupts. Okay, so 8259 role in it is a interrupt controller. Okay, which is going to be interfaced with 8085 so that your 8085 can handle more number of interrupts. Okay, in your system, if there are more number of interrupt driven data transfer are required, at that point of time we can go with 8259. Okay, so default away namak interrupt control 8085 la irukkudu, but if your system requires more number of interrupts to be handled, then you can go with 8259. Okay, so elaborate another part. Fine. Okay, so first we have to go with the features. What are the things we can do with 8259 that we have to understand. Okay, so 8259 is generally used for handling multiple interrupts from many IO devices. Okay, so 8259 is going to be an interrupt handler. You can say it is a interrupt handler. 8085 8051 interrupt control unit இருக்குன்னு சொன்னோம் இல்லைங்களா. So similarly we are having an IC 8259. It can handle interrupts. Okay, many number of interrupts from the IO devices. Okay, coming to the interrupt, who is going to initiate the interrupt process, whether the CPU or IO devices? Kindly respond. Yes. Who is going to initiate? Yes, very good. The IO device, it is going to initiate the interrupt process. Fine. Okay. So this 8259 can be programmed in 2 ways. Okay, 2 modes. One is single mode, the other one is cascade mode. Okay, in the case of single mode, it can handle a maximum of 8 interrupts. Okay, a single 8259 IC can handle 8 interrupts. Okay, in the cascade mode, what we are going to do is we will be going to have a concept called master slave configuration. Okay, you will be having one master and you will be going to have 8 slaves. Fine. So those 8 slaves, which are nothing but individual 8259. What about the interrupt handling capability of each 8259? Can you type in chat? A single 8259 can handle up to how many interrupts? 8 interrupts. Okay. If I am going to have 8 slaves, okay, each slave it is going to have 8 interrupts. It can handle 8 interrupts. So in cascade mode, maximum we can connect 8 8259 slaves. That means what? In cascade
Ram
mode.
sir.
Mugul sir.
Ram sir, from ET Aditya and Shakti Abhirami.
Okay.
இப்போ வந்து observation record submit பண்ணிட்டு இருக்காங்க.
Okay, students, if you people are submitting observation and record during the class hours, you will be marked as absent. Okay, I'm warning you. Okay, don't do any other works. Kindly listen. See, we are putting some effort to make you people to understand more concepts. Okay, don't do such things. I'm warning you. Okay, don't do. Kindly listen. Okay, can you type in chat? In cascade mode, maximum how many interrupts can be handled? I have given the clue. You will be going, yes, very good. So it can handle 64 interrupts. That means 8259 can be configured as slave, okay, whose outputs are connected to the interrupt pins of master. That means what? Each slave can handle 8 interrupts. Totally, we can connect 8 slaves with the master 8259. So it can handle 64 interrupts. Okay. See, these are the things we have to know. It's very important. Okay. So if you configure 8259 in cascade mode, maximum how many interrupts we can handle? 64 interrupts. Okay. In single mode, we can handle up to 8 interrupts. Fine. Then, what are the things we can able to program? That it's very, very important. As we told, it's a programmable interrupt controller. Can program its operation. Fine. What are the things we can able to program means we can configure the vector address of the interrupts. Okay, it's a nice thing, na? In 8085 microprocessor, the vector address of all interrupt are predefined. It is fixed. We cannot able to change it. Fine. Whereas in this case of 8259, each interrupt you can configure its vector address. Okay, with some limitation. With some limitation. That's that point I want to insist, with some limitation. Okay, that point I want to tell. Okay, in the vector address it's not like that. There are some rules are there. Okay, we have to follow that. Then we have to assign the vector address for the individual interrupts. Okay, then the byte space between the vector address of each interrupt can be either 4 byte or 8 byte location. I hope you people understand. Yes, RST0 would a vector address software interrupt. RST0 would a vector address. What is the vector address for RST0? So how we have to calculate the vector address? The number multiplied by 8, it should be represented in hexadecimal. So RST0 means n equal to 0. So what about the vector address? You must mention in 16-bit. Okay, 0000H. Okay. So 0000H. Okay, what about the vector address for RST1? Yes, what about the vector address for RST1? N equal to 1. So 1 into 8 is equal to what? No, Anthony Surya. Actually, you are representing in 16-bit address. Sorry, 32-bit address. Okay. No. See, if you convert the value, yes, Logus Nega, very good. Okay. See, actually, you are representing in binary pattern, Anthony Surya. Kindly correct it. So, address generally we will express in hexadecimal. Okay, it is a 16-bit address. So, it is difficult to represent in 16 bits in binary pattern. So, we are always used to represent with 4 digits hexadecimal value. Okay, fine. Okay, so what about the address interval between these two interrupts, software interrupts? How many byte space are there between the two interrupts? 8. Okay, so that is fixed. Clear? In the case of 8085 microprocessor, all interrupts are assign the vector address with a fixed interval. Okay, so here we have a provision to have a 4-byte or 8-byte interval location between each vector address. Okay, so each vector address can be spaced between a 4-byte or 8-byte interval. Okay, then in the case of 8085, all the interrupts are fixed with their sensitivity. Okay, you know, trap is a both edge and level sensitive interrupt. Correct? A trap in, you can have either active high, okay, or a rising edge that will trigger the interrupt. Correct? Yes or no? In the case of RST 7.5, it is only edge trigger. What about here in 8259? We can also configure that thing also. Correct? You can configure each interrupt, whether it should be edge trigger or level trigger. But remember one thing, it cannot be done individually for each interrupt. All interrupts can be either edge trigger or level trigger. Globally, we can make all interrupts can be either edge trigger or level trigger. We cannot do it for individual interrupts. Fine? Next. See, that's what I'm saying. Even if you are having a capability to program more things, you have some limitations. Okay, fine. Then it has an on-chip priority resolver. Okay, if many interrupts occurred at the same time, this 8259 will resolve the priority based on the current interrupt processing. Okay, what are the pending interrupts and what are all the interrupts masked. Okay, based on that, it will resolve the priority. Fine. Then each and every individual interrupt can be masked or unmasked. That thing we can do. Okay. See, these are the things we can able to program. Okay, using this 8259, so that the individual interrupts can be programmed. So there are two modes of priority here we are having. One is fixed priority. The another one is rotating priority. Okay. Fixed priority means what? The priority order of all interrupts are predetermined. Okay, it cannot be changed. Whereas here in 8259 we can program. There are two ways to program. One is fixed priority. The another one is rotating priority. Rotating priority means what? Say for example, I am having 8 interrupts. Okay, so one of the interrupt it is going to have the highest priority. The other it's going to be in the order. So one of the interrupt is going to have the lowest priority. This we call it as fixed priority. In the case of rotating priority, please kindly listen. In the case of rotating priority, if a high priority interrupt got serviced, then it becomes low priority. The next interrupt becomes the highest priority. Is it clear? Can we have an example for this? Can we have an example for this? Ring topology. Ring topology. So, adala enna nadakum? See, when one person comes out of the loop, okay, then he has to join at the end. Correct? Yes or no? See, நம்ம ஒரு queue ல நின்னுட்டு இருக்கோம். So first நம்ம போயிட்டு ஒரு product வாங்கியாச்சு. Fine? Once we are out of the queue, if I want to purchase some other product, what we have to follow? We have to be at the end of the queue. Correct? Yes or no? The same thing here. Rotating priority means indirectly we can say all interrupts are given important, equal priority. That means if one of the high priority interrupt got serviced, so it becomes the lowest. Okay, so there are two modes of priority. Then terminating the service. There are different ways to terminate the interrupt service. That we call it as end of interrupt eventually. Fine. It is possible to program the modes of priority of the interrupt, end of interrupt, and masking. Everything you can do dynamically. What it means dynamic? Run time la enoda programming use panni na enna pannalam? I can change the operation at any point of time. In the interrupt la enakku high priority venum. At any point of time, you can reassign the priority. Fine. Is it clear to everyone? Is it clear to everyone up to this? So we are having several advantages when we are going to use 8259. I hope it is clear to everyone. Shall I proceed to next slide? Yes. Okay, fine. Now we are going to see about the architecture of 8259. Okay. So this is the architecture diagram of 8259. Already few of the signals you people know very well. Okay, can you type what are the things you can know? You know very well about it. What about D7 to D0? What about D7 to D0? Yes, data bus. For what purpose it is used? For what purpose the data bus is available in 8259? Like 8255 and 8253, here also this bus is going to connect the CPU with your 8259 data bus, correct? Yes, for data transfer, very good. For programming your 8259, okay, so this bus, it is very, very important. Okay, so it is going to be a bidirectional bus. That means what? You can configure this 8259 as well as you can read the status of some of the registers from 8259. Fine, that's all about the purpose of D7 to D0. Okay, what about other signals you know very well? Data bus buffer, so it is going to have the information available from CPU or from 8259 to CPU. Okay, so it is going to act as a bridge. Okay, fine. Coming to this block, read-write logic block. Okay, so what are the signals we are having? RD bar, WR bar, CS bar, and A0. Okay, what about the purpose of CS bar? In 8259, in 8255 and 8253, what is the purpose of those CS bar? The same here also. What it means? When 8259 will get selected by the CPU. If 8259 select out, what about the condition required to select the 8259? CS bar 1 irundha 8259 select aguma illa 0 irundha select aguma. Yes, as it is an active low signal, whenever the microprocessor send the address, here note down only address bit A0 is having some purpose. The remaining address bit A7 to A1, it is combinedly used to generate the chip select signal. Okay, so in later slides, you will be having beautiful diagrams to understand all those things. Okay, so you will get 825553 path on link la. So adal nama interfacing diagram 8253 comes to here we are going to have an interfacing diagram for 8259 also. Okay, so eppadi nama 8085 microprocessor kuda the 8259 connect pandra step by step we will go. Okay, fine. You all of you people know RD bar and WR bar. It is going to be active low signals. Okay, so when RD bar goes low, RD bar எப்ப நமக்கு 0 ஆகும்? Yes, kindly respond. RD bar எப்ப எனக்கு 0 ஆகும்னு கேட்டேன். When we are writing, WR bar becomes 0 and RD bar becomes 1, correct? In other words, I can ask like this. Yes, during read operation, very good. Whenever your processor wish to read some content, that means status from this 8259. Okay, so at that point of time, RD bar goes low. Okay, these two signals decides the direction of communication. Okay, read panna poroma, write panna poroma. Both cannot be done at a time, obviously. Fine. If RD bar is equal to 0, what about the condition of WR bar? RD bar எனக்கு 0 இருந்தா W bar கண்டிப்பா 1 தான் இருக்கும், கரெக்ட்டா? If there is no data transfer happen between 8259 and the CPU at that point of time, what about the logic of RD bar and WR bar? What must be the logic? Both should be high. Fine. Okay, if your 8085 microprocessor is not communicating with this 8259 at that point of time, RD bar, WR bar, ரெண்டுமே நமக்கு 1-1 logic. Fine. Okay. Fine. Coming to this particular block, cascade buffer / comparator. Okay. I have told you we are having two modes of operation, correct? Single mode and cascade mode. Obviously, this particular block it can be used for cascading operation. Okay. It is somehow complex rather than the single mode operation. Okay. Single mode, cascade mode, two modes சொன்னோம்ல, single mode தான் நம்ம concentrate பண்ணலாம். Fine. As of now, this block in a purpose use ஆகுது அப்படினு பாத்தீங்கன்னா you can see CAS0, CAS1, CAS2, 3 pins we are having. Okay, using 3 pins, how many combinations you can have? 3 signal வச்சு எத்தனை combination possible நமக்கு? Is it 9? Anthony Surya? Yes, very good, Danya. What I have told you, in cascade mode, how many 8279 slaves can be connected to a single 8259 master? Yes, that's why we are having this 3 pin. See, when we are going for cascade mode operation, these 3 pins are connected to the 3 pins of all the slaves. Correct? If I am considering this as a master, CAS0, CAS1, CAS2 pin of this master is going to be connected with all the slaves. Okay, so that whenever an interrupt from a slave occurs, this master can know from which slave it is having the interrupt. Okay, so for that purpose only we are having this. Okay, I'm not going to take much time on this block. Okay, this is used for cascade mode, but in our theory course we are going to concentrate only on the single mode operation. Okay, fine. Now coming to the other blocks, here you can see how many interrupts it can handle in single mode. 8259 எத்தனை interrupt handle பண்ணனும் சொன்னோம் single mode ல 8 interrupts. Okay, can you see the signals IR0 to IR7? Yes or no? What are those 8 pins? IR0 to IR7. Here you can see IR0 to IR7. 8 pins we are having. Fine. What that pin? Yes, very good. Those are the interrupt pins. Okay. IR0 is having the highest priority and IR7 is going to have the lowest priority by default. Okay. So on the order the pins arrange பண்ணிருக்கோம். Yes. Okay. Fine. Fine. Okay. Now coming to this part, this interrupt pins are directly connected to a register. It is connected to a register. What about the name of the register? Totally we are having 3 registers internally in this 8259. Okay. So by accessing this 3 register only, the priority resolver will resolve which interrupt has to be serviced first. Okay, if multiple interrupts occur simultaneously, this priority resolver access these 3 registers: interrupt request register, interrupt mask register, in service register. By accessing this 3 register, the priority resolver will decide which interrupt have to be serviced now. Yes, is it able to understand by you people? The 3 registeroட conditions பொறுத்து தான் priority resolver என்ன பண்ணும்? It will generate the interrupt. Yes, we can have example for this and all in later slides. Okay, suppose we are considering multiple interrupts are occurring. Okay, based upon the condition of IRR, IMR and ISR, the priority resolver it is going to generate an interrupt. Okay, so for that we are having a control logic box. Okay, so this block it is going to generate the interrupt. Okay, it is going to represent there is an interrupt request for this 8259. எப்பெல்லாம் எனக்கு 8259 க்கு ஏதோ ஒரு டிவைஸ்ல இருந்து interrupt request வருதோ, at that point of time the priority resolver will resolve the priority and allow one of the interrupt to be serviced. Correct? At that point of time, this 8259 is going to generate an interrupt signal through which pin? INT pin. Is it clear to everyone? INT pin of 8259 என்ன purpose னு புரிஞ்சுதா? Based upon the priority, okay, and the other things, okay, we have what we have programmed. Based upon that, it resolve the priority. Then that particular interrupt is going to be allowed. Fine. So on the single interrupt, நமக்கு என்ன பண்ண போகுது? 8085 போய் interrupt பண்ண போகுது. Fine. So the interrupt signal generated from 8259 is at INT pin. Interrupt request to 8259 are at IR0 to IR7. Fine. The interrupt request to 8085 is generated from 8259 through INT pin. Yes, is it clear to everyone? Is it clear to everyone? Yes or no? Okay. Once this interrupt, the generated interrupt, it is reaching the 8085 microprocessor. What 8085 microprocessor has to do? நல்லா யோசிச்சு பதில் சொல்லுங்க. இங்க 8 இன்டரப்ட் இருக்கு. 8 இன்டரப்ட்டுக்கு வெக்டர் அட்ரஸ் 8259 தான் தெரியும். Your 8085 microprocessor doesn't know what is the vector address for IR0, IR1, IR2, IR7. It doesn't know. Fine. What it means? Where I have to connect the INT pin of 8259 with 8085 microprocessor? Now you people can guess. Vector address வந்து 8259 தான் கொடுக்க போகுது. அப்ப எந்த பின்ல நான் கனெக்ட் பண்ணணும்? This INT pin of 8259. Yes, very good, Anthony Surya. Fantastic. It must be connected to INTR pin. I hope you people understand now. Okay. So, if 8259 I use பண்ணனா 8259 ல இருந்து ஜெனரேட் ஆகுற இன்டரப்ட் நான் எங்க கனெக்ட் பண்ணனும்? The interrupt out generated from 8258 must be connected with INTR pin of 8085. Right? As it doesn't have vector address, it is going to ask 8259 through INTA bar pin. So INTA bar means what? INTA bar means what? Yes. INTA bar means what? Kindly respond. Yes, acknowledgement signal from 8085. Okay. So at that point of time, 8259 will give the corresponding address for the interrupt it requested. Allah note பண்ணிக்கோங்க. எந்த interrupt request வந்து இந்த interrupt generate ஆச்சோ. Fine. அந்த interruptக்கான vector address your 8259 is going to give to 8085 microprocessor. Fine. So this is the sequence happening in this architecture. Is the architecture diagram is clear to everyone? See, architecture diagrams are generally used to understand the flow of signals happening in the particular IC. Yes, very good. You people understand. Very good. Shall I proceed? So, whatever I have discussed so far in this architecture, I am going to explain in detail. Okay, each and every signal of 8259. Shall we proceed? Anything we have missed from this architecture diagram? See, in the portion pati worry panna vena. This portion we call it as for cascading purpose. This particular block is available. We are going to deal only with single mode operation. Okay. Once upon a time, in our lab experiment, okay, programming of 8259 we have done. Okay. Later point of time, 8051 la nariya experiments focus pannadanaala இந்த experiments la drop பண்ணியாச்சு. Okay, so as per the current lab experiment list, 8253 we are having. Okay, so 8259 additional number fine. But unfortunately, this semester we may not be able to do this experiment. Okay, fine. So I will move to the next slide. So now we are going to see about the signals of 8259. So data bus buffer D7 to D0. So it is used to transfer data between microprocessor and 8259. Okay. So D7 to D0, correct? So in the this 8 pins of 8259 must be connected to the data bus of 8085 microprocessor. Okay. So it is used to write the command on the command word register. So இது வரைக்கும் நம்ம control word register தான் படிச்சிருப்போம். Here we are saying command word register. Fine. So in this I missed to tell about the signal A0. Okay, see, generally நமக்கு வந்து பாத்தீங்கன்னா multiple registers இருந்துச்சுன்னா A0, A1 ரெண்டு பின் கொடுத்திருந்தாங்க. So port 0, sorry, port A, port B, port C select பண்ணோம். Regarding 8253, counter 0, counter 1, counter 2 select பண்ணோம். Fine. Coming to 8259, the purpose of A0 is something different. Something different. Okay, so that portion you will understand during the control word format, sorry, command word formats. Okay. See, the relation of A0 with the command word is, for writing some of the command word, A0 must be high. For writing some of the command words, A0 must be low. Fine. That decides what is the command word we are giving to 8259. Okay. So that we will discuss in detail. So coming to this, so this is used to read the status of the three registers, IMR, ISR and IRR. Yes, already I have told you. Fine. இங்க ரைட் பண்ண போறோம் அப்படின்னா டேட்டாவே கிடையாது. We are not going to provide any data to A2FINANE. We are going to just program. Fine. So when we are writing the command, this data bus, through that only the command is going to be written into the command word register. Okay. Similarly, when we are reading the status of the registers, IMR, ISR, and IRR, this data bus is going to be useful. So whatever the communication between 8085 and A2FINANE can be done through the data bus only. Fine. Next. So this is the signal. AD7 to AD0, we are demultiplexing as A7 to A0, D7 to D0. So D7 to D0, it is going to be connected with D7 to D0 of A2FINANE. Fine. So this is the way we have to connect the database. Next, read write control logic. Enna signal la paathom? CS bar, RB bar, WR bar, and A0. Fine. So this block resides the read write control operations. Okay. So CS bar, chip select signal. If this pin is pulled low, this A2FINANE will get selected for read or write operation. Okay. So A2FINANE select பண்றதுக்கு இந்த particular signal use ஆகுது. How this signal is going to be generated? The remaining 7-bit address A7 to A1. அதிலிருந்து வரக்கூடிய சிக்னலை நம்ம some circuit use பண்ணி we have to generate 0 such that whenever that particular pattern comes, this A2FINANE will get selected. RD bar, you people know, to enable the read operation, to read the status of A2FINANE register. WR bar, you already know, to enable the write operation to write the command words. Okay. So is this things are clear to everyone? Yes. I think somebody is unmuting and doing some noise. Okay. See, don't disturb the class. Okay. So A0, address line A0. Okay, it is used to select the command word register where command words are to be written, status of the register, from where we are going to read. Okay. So இது புரிஞ்சிக்கிறது கொஞ்சம் சிரமமா இருக்கலாம். நம்ம command word format போறப்ப you people understand it clearly. Fine. When we are writing some command word, A0 must be 1. Okay. For some other command words, when we are writing, A0 must be 0. Okay. There is some sequence of writing the command word that we will discuss later. So A0 is having some role. Okay. A0 is deciding which command word we are writing to A2FINANE. Then, now you people can see. Fine. Already I have explored AD7 to AD0 using the latch. We are converting to A7 to A0 and D7 to D0. So D7 to D0, it is directly connected to D7 to D0 of A2FINANE. Coming to address line, A0 is directly connected to A0 of A2FINANE. The remaining address bits. See, on seeing this, you people can tell. In the particular diagram, we have gate use which gate we are using? Seeing a dot irundhuchna bubbled input nu artham. Please understand. இங்க நமக்கு டாட் இருக்கு இன்புட்ல அப்படினா மீனிங் என்ன? பபிள்ட் இன்புட். நம்ம கொடுக்கிற இன்புட் காம்ப்ளிமெண்ட் ஆகி போகும். சிமிலர்லி இங்க இருந்து வரக்கூடிய அவுட்புட் வந்து காம்ப்ளிமெண்டட் அவுட்புட். தட் மீன்ஸ் வாட்? A7 must be 1. கரெக்ட்டா? A7 must be 1. A6, A5, A4, A3, A2, A1. This pins and all must be 0. Correct? So what about the address we can have for this A2FINANE? Can you people type? So A7 kandipa enna irukanum? A7, A6. I will type in chat. Kindly refer. A7, A6, A5, A4, A3, A2, A1 and A0. Totally we are having a 7-bit address, right? A7 enna logic irukum kandipa? By considering this interfacing diagram, A7 must be 1, A6 must be 0, A5 must be 0, A4 must be 0, then A3 must be 0, A2 must be 0, A1 must be 0. Okay, A0 can either be 0 or 1. Okay, either 0 or 1. Fine. So I am typing in chat. You people refer this. So what about the address for writing the command word? There are two possible addresses. What are the two possible addresses now we are having? Yes. So upper 7 bit, undefined in the pattern that 1 0 0 0 0 0 0. Fine. A0 can be either 0 or 1. So what about the possible address we can have? In the particular circuit implement பண்ணிருந்தா என்னுடைய 8259 நான் program பண்ணனும்னா what are the two address I am having? On seeing this, you people can tell. Yes, very good, Shivakumar. So you have written in binary pattern. Can you type in hexadecimal? Yes, very good. 80H or 81H. Very good, super. For writing some of the command word, we have to use the address 80. For writing some of the command word, we have to use the address 81. Fine. So that's all about this particular diagram. Okay. Then coming to this RD bar and W bar, as we are using 8-bit address, IO mapped IO scheme. So IO slash M bar along with RD bar and WR bar, we are generating IO write and IO read signal, which are connected to read bar and write bar. Fine. Is it clear up to this? The signal purpose illama adu eppadi connect pandradundradhu inga nama kaamichirom. Yes. So this portion we call it as interfacing of IO device with 8259. Okay, fine. Next slide. So read write control logic mudijachi. Next step. IR0 to IR7 interrupt request line. Already I have told you. So IO devices are connected to this line based on the priority of the device and send the interrupt request to this line. Fine. So based upon the device priority, you have to connect. By default, which interrupt is going to have highest priority here? In 8259, by default, which is going to have highest priority? Yes, very good. IR0, which is having lowest priority. Yes, which is having, yes, IR7. Okay. Coming to an example, I'm having a room. Okay, it is having some automation. I'm having a fire alarm sensor. Okay, whenever a fire detected, an interrupt must be generated to 8085 microprocessor. Then I'm having a counting operation. Whenever a person enter into the room, an interrupt must occur so that the counting operation can take place. Okay, considering this two situation, where you will connect the fire alarm sensor, IR0 or IR7? One counting operation use agudhu, innono fire alarm. Yes, suppose if I am asking you to use only IR0 and IR7 pin, yes, very good. Fire alarm sensor must be connected to IR0 because in that particular system you have to assign high priority to that device only. Okay, so based upon the requirement by the designer, which is going to have highest priority, that must be connected to IR0. Fine. So similarly, the other interrupts can be in the order. So IR0 is having highest priority, IR7 having lowest priority. Okay, coming to this diagram, you people can understand. So INT, interrupt signal from 8258, it must be connected to interrupt pin of the processor, correct? So it generates an active high output signal to interrupt the microprocessor. So where we have to connect? Connect already. This generated interrupt must be connected to which pin of 8085? INTR pin of 8085. Suppose if I connect a trap pin, what is going to happen? Suppose na trap pin la poi the INT pin connect pannira. Enna nadakum? Can you guess? Guess panna mudiyuma? Both will have vector address. Fine. Suppose in the INT pin na trap la connect panna enna agumna? Trap undana ISR routine na eludiyirukku correct ah trap interrupt. Fine. So அந்த இடத்துல நமக்கு இங்க என்ன interrupt வந்தாலும் the same program it is going to run. That means what? Even 8 interrupts la எது வந்தாலும் எனக்கு trap interrupt க்கு உண்டான service program தான் run ஆகும். Fine. That's why the INT pin of 8259 must not be connected to vector interrupt of 8085. 8085 ல vector address எந்தெந்த interruptல இருக்குதோ அந்த pinல கண்டிப்பா connect பண்ணக்கூடாது. That's why we are connecting to INTR pin. Fine. So the pin INT of 8259 must be connected to INTR pin of 8085. Fine. Then coming to INTA bar. Coming to INTA bar, it is an interrupt acknowledgement signal from the microprocessor to 8259. Okay. In response to INT signal, 8085 will send an acknowledgement signal. Okay. So it reaches to 8259 through INTA bar pin. Fine. So INTA bar pin of 8258, it must be connected to INTA bar pin of 8085 microprocessor. Is it clear up to this? So எல்லா சிக்னலும் நம்ம பார்த்தாச்சு, அதனுடைய ஃபங்க்ஷனாலிட்டி எப்படி கனெக்ட் பண்ணுன்றதும் பார்த்தாச்சு. Right? So this is going to be the final interfacing diagram. Yes. இதுல என்ன அடிஷனல் ஆட் ஆயிருக்கு? INT pin of 8259 is connected to INTR pin of 8085 microprocessor. Then INTA bar signal is connected to INTA bar of 8259. So that's all about the interfacing of 8259 with 8085 microprocessor. Is it clear up to this? So 8259 ல இந்த பக்கம் pins எல்லாம் இருக்கு, கரெக்ட்டா? Interrupt pins இங்க நம்ம காமிக்கல. So those interrupt pins are input signal to 8259. Fine. That's all about the 8259 architecture and signals. Is it clear up to this? Shall we proceed? Yes, we'll proceed. Okay. இன்னும் அந்த ஆர்கிடெக்சர் டயக்ராம்ல இந்த மூணு ரெஜிஸ்டர் அதனுடைய ரோல் என்ன அப்படின்றது நம்ம பார்க்கலாம். கரெக்ட்? So there are 3 registers in 8259 which are used when resolving the priority of the interrupt by the priority resolver. Correct? Okay. So what are the 3 registers? IRR, IMR and ISR. On seeing the name itself, you people can understand. IRR stands for what? Interrupt request register. So in that register, what it is going to be happen? On the register, என்ன information வந்து store ஆகும்? Any guess? On seeing the architecture diagram, you people can tell. Yes, very good. Interrupt request. எந்தெந்த இன்டரப்ட்ல ரெக்வெஸ்ட் பண்ணிருக்கு 8259, that information it is available in 8259. நல்லா யோசிச்சு பதில் சொல்லுங்க. When the interrupt request will get stored into the IRR. H triggered configure பண்ணா ஸ்டோர் ஆகுமா, level triggered configure பண்ணா ஸ்டோர் ஆகுமா? Can you guess? When the interrupt request will get stored into the IRR. If the interrupt is configured as level triggered, what it means? And the interrupt pin level maintain பண்ணிட்டே இருக்கும் till it is going to be serviced. That means what? Yes, very good answer, Anthony Surya. H triggered. If it is H triggered, then interrupt request will be stored into IRR. அப்படி இல்லைன்னா ஸ்டோர் ஆகாது. என்ன ஆகும்? Till the interrupt pin logic is 1 is going to be available in the IRR in the case of level trigger. And the interrupt request போயிடுச்சுன்னா மீனிங் என்ன? Service, I mean, it is not requesting at this point of time. That means request will not get stored in the case of level triggered interrupt. Okay. In the case of H triggered interrupt, when an interrupt occurs and it goes away, the request will get stored into the IRR. Fine. So IRR oda functionality எதை depend பண்ணிருக்கு? Based upon the H sensitivity. Fine. Okay. Now coming to IMR, interrupt mask register. As the name suggests, mask register. Okay. So what about the size of IRR register? Can you guess? IRR register oda size எத்தனை bit இருக்கலாம்? 8 bit. As we are having only 8 interrupts. Okay. Coming to IMR. Okay. Interrupt mask register. What about this mask register purpose? Each and every bit in the mask register correspond to the individual interrupt pin. That means what? If I write one logic in the corresponding bit position of the mask register, that interrupt will get masked. So 1 for mask, 0 for unmasking. Please remember. See, எங்கெல்லாம் enable register, interrupt enable register னு போட்டுருக்காங்களோ அங்கெல்லாம் மீனிங் என்ன? 1 பண்ணா enable, 0 பண்ணா disable. Mask னு எங்கெல்லாம் யூஸ் பண்றோமோ அந்த மீனிங் என்ன? If it is 1 means masking, 0 means unmasking. 1 na disable, 0 na enable. That's the meaning here. Okay. Then what about the last one? What it is suggesting? 8 interruptல எந்தெந்த interruptலாம் occur ஆயிருக்கு இப்போ அதை தெரிஞ்சுக்கிறதுக்கு IR currently. Fine. Then IMR எந்தெந்த interruptலாம் மாஸ்க் பண்ணுன்றதை நம்ம முடிவு பண்ணிக்கலாம். What about ISR? Any idea? See, this topic I am taking the very first time, but on seeing the name, you people can guess. In service register, what it means? What is the meaning for this? In service register. Can you guess? Yes. Here, ISR doesn't mean interrupt service routine in service register. That means 8259. Okay. After it's resolve the priority, it is requesting 8085 microprocessor to perform a service. Correct? So, இப்ப எந்த particular interrupt ஆன service program run ஆயிட்டு இருக்கு. So, to indicate that this ISR register is available. Currently, which are all the interrupt are being serviced by 8085 microprocessor. எந்தெந்த interruptக்குலாம் இப்ப service நடந்துட்டு இருக்கோ, so அந்த information ISR ல இருக்கு. That's the meaning for purpose of ISR register. Clear? So IRR ல என்ன இருக்கும்? Which are all the interrupt are currently requesting or pending அந்த information இருக்கும். IMR ல என்ன information இருக்கும்? Which are all the interrupt has to be masked. That information is available in IMR. In ISR, which are all the interrupt are currently serviced by 8259. Say for example, ஒரு high priority interrupt ஒரு low priority interrupt service ஆயிட்டுக்குன்னு வச்சுக்கலாம். அப்போ ஒரு high priority interrupt வந்தா என்ன ஆகும்? Can you guess? Multiple interrupt occur ஆயிருக்கு. Currently low priority interrupt service ஆயிட்டு. இது service ஆயிட்டு இருக்கப்ப high priority interrupt வருது. அப்ப மீனிங் என்ன? Which one must be given higher priority? Say for example, IR0 to IR7 ல IR6 current நமக்கு interrupt request வந்திருக்கு. Suppose suddenly IR0 interrupt request வந்தா, which is going to be serviced. Okay, அப்ப IR6 ஓட service program என்ன ஆகும்? Any guess? It will come out of the, yes, very good Danya, very good, fantastic. IR6 ஓட சர்வீஸ் பாஸ் பண்ணிட்டு தான் IR0 கண்டினியூ ஆகும். கரெக்ட்? அப்ப மீனிங் என்ன? IR0 முடிஞ்ச உடனே திரும்ப IR6 ஓட சர்வீஸ் ப்ரோக்ராம் கண்டினியூ ஆகும். கரெக்ட்? am I correct? அப்ப மீனிங் என்ன? IR0 க்கு சர்வீஸ் நடந்துட்டு இருக்கு, IR6 ஓட சர்வீஸ் பாஸ் ஆயிருக்கு. That means it is also in service now. Now you people can understand. ISR பிட்டோட மீனிங் என்னன்னு புரிஞ்சிருக்கு. எந்தெந்த இன்டரப்டுக்கெல்லாம் சர்வீஸ் நடந்துட்டு இருக்கோ, அதோட சர்வீஸ் இன்னும் முடியலையோ, அந்த பர்டிகுலர் இன்டரப்டோட கரஸ்பாண்டிங் ISR பிட் செட் ஆயிருக்கும். Is it clear to everyone? Is it clear to everyone? Yes, fine. Okay. So now you people can know. So IRR means interrupt request register. So it's a 8-bit register. So எப்ப செட் ஆகும்? When interrupt request either edge triggered or level triggered. Okay. But in the case of edge triggered, the request will be stored. That means when an interrupt comes and goes away, the request will get stored in the case of edge triggered. In the case of level triggered, when interrupt is occurring at high level, so it has to be serviced. But எனக்கு 8259 பிஸியா இருக்குன்னு வச்சுக்கலாம். அந்த பாயிண்ட் ஆஃப் டைம்ல அந்த இன்டரப்ட் எனக்கு திரும்ப லோ ஆயிடுச்சுன்னா இட் ஒன்ட் பி கன்சிடர். தட்ஸ் தி மீனிங் ஃபார். சிம்பிளா சொல்லணும்னா கிளாஸ் எடுத்துட்டு இருக்கப்ப ஒரு 10 பேர் டவுட் கேட்கறோம்னு வச்சுக்கலாம். ஃபைன். மீனிங் என்ன? யாரோ ஒருத்தவங்களுக்கு ஃபர்ஸ்ட் நான் டவுட் கிளியர் பண்ணணும். கரெக்ட்? நான் கிளியர் பண்ணிட்டு அடுத்த டவுட் யாருக்காவது இருக்கான்னு கேட்கறப்ப யூ பீப்புள் ஹாவ் டு பி ரெஸ்பாண்ட். அதர்வைஸ் வாட் ஐ வில் டூ, I won't do the service. Level trigger na idha mean. Edge trigger na meaning என்ன? I have to remember who are all asked doubt. I will go one by one based upon the priority. Is it clear to everyone? Edge level difference புரிஞ்சுதா? கரண்டா எந்தெந்த இன்டரப்ட்லாம் எனக்கு இன்டரப்ட் பண்ணிட்டு இருக்கோ அதை மட்டும் கன்சிடர் பண்ணா அது பேரு லெவல் ட்ரிகர். எட்ஜ் ட்ரிகர் தான் மீனிங் என்ன? Interrupt request store item. After I have resolved the high priority interrupt and service it, I will go with the next level priority. Fine? Okay. So the bits of IRR gets reset. Epa reset agum? It's very, very important. Epa reset agum? Once the priority resolver resolves a particular interrupt to be serviced, at the point of time, the IRR bit automatically clear item. Is it clear to everyone? எப்ப செட் ஆகுது? இன்டரப்ட் ரெக்வெஸ்ட் வர்றப்ப செட் ஆகும். கரெக்டா? எப்ப கிளியர் ஆகும்? ஒன்ஸ் அதோட இன்டரப்ட் அக்னாலஜ் ஆயிடுச்சு. ஐ மீன் இட் இஸ் அக்செப்டட் பை 8259 அப்படின்னு சொன்னோம்னா இட் வில் கெட் ஆட்டோமேட்டிக்லி கிளியர். ஓகே. So you can see on this diagram, you can see what are all the interrupt are currently pending. எதெல்லாம் ரெக்வெஸ்ட் பண்ணிட்டு இருக்கு? Pending or requesting. You can take it in either way. On seeing this, you can respond. Out of the 8 interrupts, which are all the interrupts are currently pending? Yes, interrupt IR0 and IR4. Very good. Then now we'll go with the mask register. So each bit it is going to be used to mask or unmask the interrupt. Okay. Inga set panona meaning enna? Masked. 0 panona meaning enna? Unmasked. Correct? So individually you can mask or unmask any interrupt using this IMR. Okay. Can you people type in chat which are all the interrupts are masked in this particular diagram? Endha interrupt la mask aayirukku parunga. IR3 and IR5. Very good. Super. Okay. Next, in service register. So already I have told you. So this corresponding bit of each interrupt is going to set when it is currently being serviced. Currently, for the service நடந்துட்டு இருக்கு அப்படின்னா அதனுடைய ISR bit set conditionல தான் இருக்கு. Fine. It holds the status of the interrupt pending being serviced. Okay. இது எப்ப reset ஆகும் சார்? Can you people guess? IRR interrupt request accept ஆன உடனே reset ஆயிடும். கரெக்டா? IRR எப்ப reset ஆகும்? Whether it automatically gets reset or we have to do it. Yes, very good. Once completing the service program, அப்பனா மீனிங் என்ன? அதோட ISR routine விட்டு வெளியில வர்றப்ப நம்ம ப்ரோக்ராம்ல எழுதி இருக்கணும் இதோட சர்வீஸ் இதோட முடிஞ்சு போச்சுன்னு. எழுதாம விட்டா என்ன ஆகும்? இன் சர்வீஸ் மாதிரி தான் கன்சிடர் ஆகும். ஃபைன். So here we have to note down one thing. We have a procedure to reset the ISR bit. This we programmer must do in the ISR routine end. ISR routine oda end la நம்ம இதுக்கு ஒரு கமாண்ட் கொடுத்திருக்கணும். எதுக்காக? To clear the ISR bit of the particular interrupt service routine. Okay, that indicates in the particular interrupt oda service முடிஞ்சு போச்சு. Fine. So when it is going to get reset, எப்ப செட் ஆகுது? Once 8085 accept the service, எப்ப reset ஆகும்? Once its service get completed, correct? By issuing suitable end of interrupt command. As I told, we have to give a command from 8085 to 8259 in the ISR routine. ISR program end la na enna pannu or command kudukanum. EOA command solluvaanga per end of interrupt command. The command kuduthomna da enakku enna agum? The corresponding ISR bit will get clear. Is it clear to everyone? See, 8259 program பண்றது it's not going to be a simple thing. Okay. See, நான் சொன்னேன் இல்லைங்களா 8259 லேப் எக்ஸ்பெரிமெண்ட்ல வச்சிருந்தோம்னு சொல்லி. So at that point of time 8259 எக்ஸாம்பிளோட சொல்லி கொடுக்கும். Okay. For example, IR0 வந்துச்சுன்னா எனக்கு இந்த மெமரியில் உள்ள டேட்டாவும் இந்த மெமரியில் உள்ள டேட்டாவும் ஆட் ஆகணும். கரெக்ட்? இந்த இன்டரப்ட் வந்தா சப்ராக்ட் ஆகணும். ஓகே, இந்த இன்டரப்ட் வந்தா காம்ப்ளிமெண்ட் ஆகணும். லைக் தட் we have write program. Okay. Clear? See, understanding the concept of 8259 is easy in single mode. Fine. Single mode நமக்கு புரியல அப்படின்னா cascade mode போனோம்னா இன்னும் காம்ப்ளிகேட்டடா ஆயிடும். That's why we are focusing on single mode operation. Okay, that's the reason. Okay, on seeing this you people can tell எந்த இன்டர்ப்ட் மட்டும் இப்ப சர்வீஸ் நடந்துட்டு இருக்கு கரண்டா? IR6. Okay, அதோட சர்வீஸை நான் டெர்மினேட் பண்ணனும்னா என்ன பண்ணனும்? End of interrupt command I have to issue so that the IR6 bit must be clear at the ISR routine end of the ISR program. ISR program oda end la definitely நம்ம வந்து end of interrupt command எழுதலனா என்ன ஆகாது? இந்த interrupt oda service terminate ஆகாது. அப்ப ISR bit clear ஆகாது. அப்ப இதை விட low priority interrupt வந்தா அது ஜென்மத்துக்கும் acknowledge ஆகாது. Fine? Is it clear to everyone? Okay, fine. So coming to priority resolver. So it access the three register IRR, IMR and ISR and going to resolve the priority of the interrupt. First it access IRR. Endha interrupt na pending la irukku. Yes, that thing it has to understand. Adutha vandirukka interrupt la edadella mask aayirukku that it has to check. Okay, then idha vida high priority interrupt service la irukka that it has to understand. Okay, after it knows all the three information, it will decide which interrupt can be allowed to service. Yes, so that is the work done by the priority resolver. Okay, so idhula main ana block அப்படின்றது பாத்தீங்கன்னா இந்த priority resolver தான். Yes, is it clear? இதுக்கு 8085 ல நமக்கு பார்த்த மாதிரி ஒரு சர்க்யூட் இன்டர்னலா இருக்கும். சோ அத பத்திலாம் நம்ம டீடைலா படிக்கல. Priority resolver is a block. It is going to have the access over IRR, IMR and ISR. Based upon the condition of IRR, IMR and ISR, it will accept one of the interrupt and generate the interrupt signal. That's all. Fine. At any point of time, alla oru vishayam note pannikonga, interrupt அப்படினு சொல்லிட்டோம்னாலே at any point of time only one interrupt can be serviced. Okay, fine. Shall we move to next slide? Yes. Okay, next slide la ஒரு எக்ஸாம்பிள் நான் கொடுத்திருக்கேன். இந்த எக்ஸாம்பிள் பார்க்கலாம். Okay, அடுத்த ஸ்லைட்ல வருது. If the interrupt request is in pending, non-masked and there is no high priority interrupt request being serviced, then priority resolver accept that particular interrupt. என்னென்ன கண்டிஷன் செக் பண்ணுது? கரண்டா பெண்டிங்ல இருக்கணும். ஓகே, மாஸ்க் பண்ணிருக்க கூடாது. இதை விட ஹை priority interrupt சர்வீஸ்ல இருக்க கூடாது. இந்த மூணு கண்டிஷனை பொறுத்து தான் ஒரு interrupt நமக்கு accept 8259. Is it clear? Okay, so once the interrupt request of 8085 from the IO device is accepted, அதோட ISR bit நமக்கு என்ன ஆயிடும்? கண்டிப்பா செட் ஆயிடும். Fine. IRR bit என்ன ஆயிடும்? IRR bit reset ஆயிடும். Okay, after the service of an interrupt is completed, then its corresponding ISR bit must be cleared by the software using suitable end of interrupt command. So அதான் நான் சொன்னது, இந்த கிளியர் பண்ணாம விட்டோம்னா என்ன ஆகும்? இந்த பர்டிகுலர் இன்டரப்டுக்கு லோ லெவல் உள்ள எந்த இன்டரப்டுமே சர்வீஸே ஆகாது. So it's very very important. End of interrupt command, it's mandatory after the service is over. Okay, fine. So இந்த டயகிராம் பார்த்ததுல இருந்து என்ன அண்டர்ஸ்டாண்ட் பண்ணிருக்கீங்க? எந்தெந்த இன்டரப்ட்ல இப்ப பெண்டிங்ல இருக்கு ஆர் ஸ்டில் ரெக்வெஸ்டிங் தி 8259? Yes. On seeing this, you can tell me the answer. எந்தெந்த இன்டரப்ட்ல இப்ப சர்வீஸ்ல இருக்கு? Request பண்ணிட்டு இருக்கு. Which are all the interrupt are requesting to 8259? Yes, IR0, IR2 and IR6. 3 interrupt, correct? IR2 miss பண்ணிட்டீங்கன்னு நினைக்கிறேன். லோகஸ் நேகா, kindly check. So 3 interrupts are requesting to the priority resolver of 8259. Okay, இதுல எந்தெந்த இன்டரப்ட்ல மாஸ்க் ஆயிருக்கு பாருங்க. சோ இது MSB ன்னு எடுத்துக்கலாம், இது LSB ன்னு எடுத்துக்கலாம். ஓகே, எந்தெந்த இன்டரப்ட்ல இதுல மாஸ்க் பண்ணிருக்காங்க? IR0, IR2, IR6 மூணு ரெக்வஸ்ட் பண்ணுது. அதுல எதெல்லாம் மாஸ்க் ஆயிருக்கு பாருங்க. IR0 and IR6 ரெண்டும் மாஸ்க் ஆயிருக்கு. அப்ப எந்த இன்டரப்ட் ஸ்டில் மாஸ்க் பண்ணாம இருக்கு? அவுட் ஆஃப் த 3 இன்டரப்ட் IR2. வெரி குட். Now coming to ISR, in service register bit, இதுல மேல உள்ளது 0, கீழ உள்ளது 7 எடுத்துக்கலாம். இதுல எந்த இன்டரப்ட்க்கு கரண்டா சர்வீஸ் நடந்துட்டு இருக்குன்னு சொல்ல முடியுமா? IR4. வெரி குட். whether IR4 is high priority than IR2? No. Which is having high priority? IR2 is having high priority. அப்ப என்ன ஆகும்? IR4 service routine is going to be passed. அந்த சர்வீஸ் ரூட்டீன்ல இருந்து வெளியில வந்துட்டு எந்த இன்டரப்ட் நமக்கு சர்வீஸ் நடக்க ஆரம்பிக்கும்? IR2. That's all. Very good. Super, Anthony Surya. In this way, it can handle 8 interrupts. Okay, fine. Is it clear to everyone? So priority resolver எப்படி work ஆகுதுன்னு புரிஞ்சுதா? Which are all requesting and which are all masked, so that will be eliminated. The remaining interrupts, it will compare with ISR bit. If ISR bit of that particular bit, sorry, an interrupt is set, it will check whether the in-service interrupt is having highest priority. If no, then it will permit the interrupt. Okay, so this is the thing happening in 8259 priority resolver. Okay, now we are going to see what are the things going to happen when an interrupt occurred in 8259. பார்க்கலாமா? ஓவராலா பார்த்துப்போம். இது வரைக்கும் நம்ம பேசினது எல்லாத்தையும் கன்க்ளூட் பண்ணி பார்க்கலாம். Fine. When one or more interrupt, I think here it is OR, not ARE. 24th slide. Sorry. So one or more. If one or more interrupt occurred at IRR. Okay, it stores the request. Okay, the priority resolver by accessing IRR, IMR, and ISR, it will solve the priority. Okay, then the microprocessor 8258 is going to send INT signal. Correct? புரிஞ்சுதா புரியலையாப்பா? After resolving the priority, 8259 என்ன பண்ணுது? It is generating the interrupt through INT signal. Okay, in turn, microprocessor என்ன பண்ணுது? Send an acknowledgement signal at INTA bar. What it means? What is the meaning for this INTA bar signal? இந்த இன்டரப்ட்க்கு சர்வீஸ் பண்ணனும் ரெக்வெஸ்ட் பண்ணுது 8259. Microprocessor பதிலுக்கு INTA bar signal send பண்ணுது. What is the meaning for that? I am ready to do your service. Can you provide the vector address? Can you provide the address for the particular interrupt? அதானே கேட்க முடியும். Yes, the meaning for interrupt acknowledgement is kindly provide me the address for the interrupt for which you have generated. Correct? So what 8259 has to respond? It has to give the address for the particular interrupt. Correct? இப்போ வெக்டர் அட்ரஸை கொடுக்கணும். நம்ம ஆல்ரெடி ப்ரோக்ராம் பண்ணி வச்சிருக்கோம், அசியூம் பண்ணிக்கலாம். ஒரு இன்டரப்ட் வந்துருச்சு, அதுக்கான வெக்டர் அட்ரஸ் 8259 இருக்கு. That has to be provided to 8085. எப்படி கொடுக்க முடியும்? First INTA வரப்ப என்ன பண்ணணும் பாருங்க. Okay, after INTA bar is received by 8259, IR bit of the interrupt request register is reset to indicate that request is accepted. Then ISR bit of the interrupt set ஆகும். Okay, so இது first நடக்கும். First INTA வரப்ப என்ன ஆகும்? IRR bit of that interrupted device, அதனுடைய corresponding bit IRR reset ஆகும், ISR set ஆகும். Correct? Okay, next it also send the opcode of call instruction. Correct? Call instruction or opcode in CD. In hexadecimal it is mentioned CDH, not CD, CDH. So it is CDH. Okay, so in the particular opcode, first INTA bar வந்தோடனே என்ன போகுது? Call instruction ஓட opcode. Fine. இப்போ microprocessor என்ன பண்ணும்? It will decode the opcode CD. Fine. After decoding, what microprocessor understand? it need a vector address which must be provided by 8259. Correct or not? Is it correct or not? See, 8085 first time INTA bar signal generate பண்றப்ப IRR bit reset ஆகும், ISR bit of the particular interrupt set ஆகும் சொன்னோம். Immediately it will send the opcode through the data bus buffer. Correct? Data bus buffer வழியா CD அப்படின்ற வேல்யூ சென்ட் பண்ணுது. After decoding the instruction CD, what microprocessor understand? Kindly type in chat. என்ன அண்டர்ஸ்டாண்ட் பண்ணிருக்கோம் 8085 microprocessor? Okay, ஒரு call address நமக்கு வேணும். Who has to provide the address? Opcode CD போயிடுச்சு. Correct? It need a 16-bit address. There only the ISR routine for the particular interrupt is available. Correct? So what 8259 has to do again? 8085 has to do again. Again it will send INTA bar. ஏன் ரெண்டு தடவை INTA bar send பண்ணுது? Is it possible to read a 16-bit address through a 8-bit data bus? Yes, as the address is 16-bit, okay, it requires 2 more INTA. Okay, adula ஒரு INTA ல என்ன போகும்? Lower byte of the address, correct? So when 8259 receives second INTA bar, it sends the lower byte of the vector address of the corresponding interrupt. During third INTA, higher byte of the vector address போகும். So once it receives the vector address, 8085 start executing the service program for the particular interrupt. Correct? So during third INTA, என்ன ஆயிடும் ஆட்டோமேட்டிக்கா ISR bit clear ஆயிடும். If end of interruptல நிறைய மெத்தட் இருக்கு, ஆட்டோமேட்டிக் end of interruptனு ஒரு மெத்தட் இருக்கு. ஸோ அந்த மெத்தட் நம்ம கான்ஃபிகர் பண்ணியிருந்தோம் அப்படின்னா at the end of the third INTA ஆட்டோமேட்டிக்கா ISR bit clear ஆயிடும். That means what? நம்ம end of interrupt command கொடுக்க தேவையில்லை, ஆட்டோமேட்டிக்கா அதுவே நடந்துடும். That's the meaning for it. Okay, fine. So இப்போ ISR program run ஆகும். The program sequence is transferred to the memory location specified by the call instruction. Correct? Vector address கிடைச்சிருச்சு. Yes, at the end of vector address, sorry, at the end of ISR routine, after completion of the service program, the MPU must issue EOI command. So அது கொடுத்தாதான் என்ன ஆகும்? அதனோட ISR bit clear ஆகும். Automatic end of interrupt இருந்தால் இது பண்ணணும்னு அவசியம் இல்லை. There are 2 more other methods for end of interrupt. So அது program பண்ணிருந்தோம் அப்படின்னா we have to give. There are 3 methods to terminate the service. Okay, so அதுல 3 end of interrupt command இருக்குது. Fine, method இருக்கு. So அதுல automatic end of interrupt நம்ம சொல்லியிருந்தோம்னா மீனிங் என்ன? நம்ம end of interrupt command கொடுக்க வேண்டாம். அதோட interrupt service program உள்ள போன உடனே ஆட்டோமேட்டிக்கா ISR bit clear ஆயிடும். Otherwise we have to give the end of interrupt command at the end of ISR routine. Okay, so end of interrupt EOI command அப்படின்னா என்னன்னு பார்க்கலாம். See, end of interrupt command நம்ம கொடுத்தா மீனிங் என்ன? ISR bit கிளியர் பண்ண போறோம். எந்த interruptக்கான சர்வீஸ் நமக்கு நடக்குதோ அதனுடைய ISR bit நம்ம கிளியர் பண்ண போறோம். That's the meaning for it. Okay, so the process of resetting the ISR bit of an interrupt whose service has to be ended. எந்த interruptோட சர்வீஸை நம்ம end பண்ணணுமோ அதனுடைய ISR bit கிளியர் பண்ற ப்ராசஸ் பேர் தான் என்னது? end of interrupt. Okay, there are 3 types of end of interrupt command. என்னென்னு பார்த்தீங்கன்னா automatic end of interrupt, non-specific EOI, specific EOI. Okay, so automatic end of interruptனா நம்ம ஆல்ரெடி சொல்லியாச்சு, நம்ம end of interrupt command கொடுக்க தேவையில்ல. Once the ISR routine starts, okay, at that point of time automatically ISR bit of the corresponding interrupt clear ஆயிடும். அது பேர் தான் automatic end of interrupt. மீதோ 2 மெத்தட் இருக்கு. அது என்ன? நான் ஸ்பெசிபிக் EOI அப்படின்னா மீனிங் என்னன்னா இந்த கமாண்ட் நம்ம கொடுத்தோம்னா இப்ப எனக்கு ISR பிட்ல நிறைய பிட்ஸ் நமக்கு செட் ஆயிருக்கும். ஃபார் எக்ஸாம்பிள் ஒரு இன்டரப்ட் பாஸ் ஆயிட்டு இன்னொரு இன்டரப்ட் சர்வீஸ் ஆகலாம், அது பாஸ் ஆயிட்டு இன்னொரு இன்டரப்ட். ஸோ 3 இன்டரப்ட் இப்ப நமக்கு இன் சர்வீஸ்ல இருக்கிறதா இருக்கும். ஃபைன், நான் ஸ்பெசிபிக் EOI கொடுத்தோம்னா இப்ப ISR பிட்ல எது ஹை ப்ரையாரிட்டியோ அதோட பிட் மட்டும் கிளியர் ஆகும். சே ஃபார் எக்ஸாம்பிள் IR0, IR2, IR5 3 இன் சர்வீஸ் இருக்குன்னு வச்சுக்கலாம். இப்போ நான் நான் ஸ்பெசிபிக் EOI கமாண்ட் கொடுத்தா என்ன ஆகும்? IR0ஓட ISR பிட் மட்டும் கிளியர் ஆகும். அது நான் ஸ்பெசிபிக். We won't specify which interrupt ISR bit has to be clear. Either high priority interrupt or other ISR bit automatically clear. Correct? Specific UI meaning enna, we are specifying in the interrupt order service and terminate pandra. That is the meaning for it. Okay. So automatic end of interrupt means if automatic end of interrupt command is issued, the ISR bit of the interrupt which is accepted gets reset during the falling edge of third INT. As I told, the interrupt service routine kulla pona odane automatically namakku adoda ISR bit clear aayidum. That is the method we call it as automatic end of interrupt. In the case of non-specific EUI, ISR bit of the highest priority currently being serviced is a type. Okay. Then specific EUI appadina meaning enna? We are specifying this ISR bit of this particular interrupt must be reset. There are three methods. Okay. Then coming to programming. So 8259 can be programmed in a sequence on a suitable command word register specified by A0 address line. So A0 line will decide which type of command word we are giving. Okay. 1 irunda some set of command word, 0 irunda other set of command word. Okay. So there are two set of command words we are having. One is initialization command word. The other one we call it as operation command. Okay. The name itself suggests initialization means before accepting an interrupt, 8259 must be initialized. So the initialization command word enna purpose kaga use pannom paakalam. Similarly, operation command word enna purpose kaga use agudum paakalam. So here we are having broadly two types of command word. One is initialization command words, the other one is operation command. Okay. So the initialization command word edukkaga use pandrona to fix few of the things in 8259. Okay, that cannot be that can be changed dynamically, but it is meaningless. ஒரு சிஸ்டம்ல என்னோட சிஸ்டம் இப்படிதான் இருக்கு, சிங்கிள் மோட்ல இருக்கு. ஸோ இந்த இன்டரப்ட் தான் எனக்கு ஹை ப்ரையாரிட்டி, இதெல்லாம் லோ ப்ரையாரிட்டி பை டிஃபால்ட் எல்லாமே அசைன் பண்ணுறோம். கரெக்ட். Similarly, vector address assignment, everything we call it as initialization. Sensitivity of the interrupt, everything we are fixing, that we call it as initialization. Those operations can be done with ICWs, initialization command word. Similarly, operation command word means at any point of time you can change the operation. Say for example, I can mask some other interrupt and unmask some other interrupt. Okay, I can change the priority order. Okay, those things can be done in operation command. Okay, first we will go with the initialization command. So this must be given in a sequence. Nalla nyabam vechukonga, ICWs அப்படின meaning என்ன? Many number of, that means 4 number of initialization command words are there that must be given in a sequence. That's very very important. Initialization command word ரேண்டமா கொடுக்க முடியாது. 4 command word இருக்குன்னா அந்த 4யும் ஒரு சீக்வென்ஸ்ல தான் கொடுக்க முடியும். After you have given the initialization command word only, your 8259 is ready to accept an interrupt. Okay. There are 4 ICWs, ICW1, ICW2, ICW3 and ICW4. அதுல ICW1 and ICW2 என்னென்னதெல்லாம் இனிஷியலைஸ் பண்ணனும்னு பாத்தீங்கன்னா சிங்கிள் மோடா, கேஸ்கேட் மோடா, then vector address of the interrupt, address byte interrupt 4 byte 8 byte ஒவ்வொரு வெக்டார் அட்ரஸ்க்கும் இடையில, then edge trigger or level trigger. Okay, so these are the things it is going to be fixed by this two command word, ICW1 and ICW2. Okay, இது எந்த சீக்வென்ஸ்ல கொடுக்கணும் அப்படின்றது பார்க்கலாம். ICW1 it is mandatory, then ICW2 it is also mandatory. After giving ICW1 and ICW2, it will check. ICW1 ல நான் சொல்லியிருப்பேன் இது சிங்கிள் மோடா, கேஸ்கேட் மோடா. கரெக்டா? சிங்கிள் மோட் அப்படின்னு சொன்னா மீனிங் என்ன? ICW3 is not going to be important. கேஸ்கேட் மோடா இருந்தா தான் ICW3 கொடுக்கணும். இல்லனா என்ன பண்ணலாம்? It check ICW4 வேணுமா வேணாமா. That means what? ICW1 and ICW2 are mandatory command word to initialize the 8259, and ICW3 and ICW4 are optional command word. Can you understand what I am saying? 8259 initialize பண்ணனும்னா ரெண்டு கமாண்ட் வேர்ட் கண்டிப்பா கொடுத்தாகணும். ICW1, ICW2. ICW3 and 4 are optional. அது வேணுமா வேணாமான்றத ICW1 டிசைட் பண்ணியிருக்கோம். அதான் இங்க சொல்லியிருக்கோம். ICW1 and ICW2 are the must command words, and ICW3 and ICW4 are optional. Cascade mode தான் ஜெனரலா அதை ப்ரிஃபர் பண்ணுவோம். Fine. Is it clear to everyone? டோட்டலா 2 டைப் ஆஃப் கமாண்ட் வேர்ட்ஸ் இருக்கு. ஒரு செட்டை வந்து இனிஷியலைசேஷன் கமாண்ட் வேர்ட்னு சொல்றோம். The another set we call it as operational command word. Initialization command word are mandatory to initialize the 8259 so that it can accept the interrupts. Okay. So அதுல ICW1, ICW2 என்னென்னலாம் ப்ரோக்ராம் பண்றோம் அப்படின்னு பாத்தீங்கன்னா single mode or cascade mode, vector address of the interrupt, 4-byte or 8-byte interval, level trigger or edge trigger. So all those things we are programming using this 2 command word. Fine. The ICW1 நான் என்ன பண்ணிடுவேன், single mode cascade mode டிசைட் பண்ணிடுவேன். ICW4 வேணுமா வேணாமான்றதை டிசைட் பண்ணுவேன். That means ICW1 and ICW2 are mandatory must command word to initialize 8259. Fine. Based upon the ICW1 command word you are giving, ICW3 and ICW4 may or may not be required. Okay, it's based upon the ICW1 itself. Okay, ICW1 command word format pakalama. So see here, many things are there. That's what I am told you. That's what I am telling. Okay, 8255 or 8253 are easy program பண்றது பண்ணிட்டு போயிடலாம். Okay, coming to 8259, you have to understand more concept to program 8259. That's why it is complex. Fine. Most of the colleges they are not doing experiment on 8259. 8259 என்னன்னு கூட அந்த ஸ்டூடண்ட்ஸ்க்கு தெரியாது. What's the meaning for that? Without understanding the concept of 8259, it's very complex to program it. Okay, so now we'll go with the ICW1 word format. That's why we are also limiting to the modes of operation. Cascade mode la போனா இன்னும் கன்ஃபியூஸ் ஆயிடும். என்ன சார் படிக்கிறதா வேணாமா அப்படின்ற மாதிரி ஆயிடும். Okay, fine. So this is the format. Generally நம்ம கண்ட்ரோல் வேர்ட்ல பார்த்தோம் இல்லையா, எத்தனை பிட் ஃபார்மட் கொடுத்திருந்தோம். What about the format size? Kindly type in chat. So இந்த ஸ்லைடோட ஸ்டாப் பண்ணிக்கலாம். இது கரெக்ட். Yes, 8 bit. Okay, can you observe something different from this command word format? Yes or no? What about the difference? You are having the command word and this command control word and this command word. How many bits we are having in this format? 9 bit. What about the odd bit available in the 9 bits? Can you see it and tell me? Yes, very good. A0. Very good. The bit A0, actually it is not part of the command word, but it is also considered with the command word, so that ICW1 நான் கொடுக்கணும் அப்படின்னா என்னோட அட்ரஸ் என்ன இருக்கணும், 80 or 81. On seeing this you can tell. On seeing this you people can tell. ஆல்ரெடி சொன்னோம் இல்லையா, 80 81 ரெண்டு அட்ரஸ் இந்த சர்க்யூட் டயக்ராம் வச்சு சொன்னோம். கரெக்டா? Fine. To write this particular command word ICW1, which address I have to prefer, 80 or 81? Yes, very good. As A0 equal to 0, obviously address become 80. Correct? Okay, coming to the other 8 bits. In the 8 bit la namak edhukku use aga podhu, command word ka use agum. Actually the command word is 8 bit only. Okay, but this format is having 9 bit to tell the address where I have to write the command, where I have to write this particular command. Okay, coming to IC4, in the bit 1 na enna 0 na enna, in the bit na 1 panna meaning enna? What is the meaning for this? இந்த பிட்டை நான் 1 பண்ணா மீனிங் என்னப்பா, இங்கே டிசைட் பண்ணிடுறேன். ICW4 கமாண்ட் வேணுமா வேணாமா, whether it is needed or not needed. Yes, yes or no? Yes or no? Yes. Okay, what about the next bit? SNGL, single mode. அப்ப மீனிங் உங்களுக்கே தெரிஞ்சிருக்கும். இந்த பிட்டை 1 பண்ணா மீனிங் என்ன? இந்த பிட்டை 1 பண்ணா மீனிங் என்ன? Single mode. 0 panna cascade mode. Very good. Then ADI stands for address interval. ஒவ்வொரு இன்டரப்டோட வெக்டார் அட்ரஸ்க்கும் இடையில 4 byte இன்டர்வல் இருக்கணுமா 8 byte இன்டர்வல் இருக்கணுமா தட் கேன் பி டிசைடட் 1 அப்படின்னு போட்டா 4 byte இன்டர்வல் 0 அப்படின்னு போட்டோம்னா 8 byte இன்டர்வல் இஸ் இட் கிளியர் டு எவ்ரிவன் இன்னொரு விஷயம் ப்ரோக்ராம் பண்ணலாம்னு சொல்லியிருக்கேன் கரெக்டா அது என்ன சிங்கிள் மோடா கேஸ்கேட் மோடா அட்ரஸ் இன்டர்வல் 4 byte 8 byte வேற என்னன்னா ப்ரோக்ராம் பண்ணலாம் priority லேட்டர் பார்க்கலாம் priority நம்ம ப்ரோக்ராம் பண்றதுன்றது it is not a initialization by default ஆவே priority assign ஆகும் very good Anthony Surya H or level triggered LTIM stands for level triggered or H triggered mode okay input mode okay level triggered or H triggered mode LTIM okay LTIM stands for in which mode we are programming okay level triggered or H triggered interrupt mode okay so LTIM means level triggered interrupt mode nu artham appo 1 panna meaning enna level triggered 0 panna meaning enna H triggered okay then coming to default bit it is 1 we cannot able to change it kandipa adu 1 da okay then remaining 3 bits inga enna irukku appdin pathina to fix the upper 3 bit of the lower byte of the vector address nalla gavanikkanum A7 A6 A5 actually vector address பொறுத்த வரைக்கும் 16 bit கரெக்ட்டா அதுல ICW1 ல lower byte of the vector address fix ஆயிடும் lower byte of the vector address fix ஆயிடும் எப்படி A7 A6 A5 இந்த பர்టిక్యులர் 3 பிட் மட்டும் தான் நான் fix பண்ண முடியும் remaining bits எல்லாம் based upon the byte interval it is predetermined okay I'm sorry the time is 12:45 okay with this slide I'm going to stop okay with this I'm going to wind up the session so I'm going to stop the recording in the next class we will continue from ICW1 word format itself okay we have some examples also okay probably in a program நம்ம எழுத போறது இல்ல okay we are not going to do the lab experiment fine but you people know it program முடிஞ்சா நம்ம டிஸ்கஸ் பண்ணலாம் fine so still என்னென்ன டாபிக் நமக்கு ரிமைனிங் இருக்கு 8259 முடிஞ்சிருச்சுனா 8279 8251 then 8237 three more ICs we have to study then application of 8085 microprocessor okay so that's all about module 2 most probably we will wind up module 2 in time okay so now I am going to stop the recording so thank you for listening.